Hello everyone, welcome to Using MongoDB with Flask. I'm Isaac, and today we'll be going through the features of MongoDB and creating a web application and API with Flask to interact with a database for a blog app. MongoDB is a NoSQL database, which has several differences from SQL databases like MySQL or SQL Server. SQL databases use structured query language for defining and manipulating data. On one hand, this is extremely powerful, right? SQL is one of the most versatile and widely used options available. It's also a very safe choice and especially great for complex queries. On the other hand, it can be very restrictive. SQL requires that you use predefined schemas to determine the structure of your data before you work with it. In addition, all of your data must follow the same structure. This can require significant upfront preparation, and it can mean that a change in the structure would be both difficult to manage and disruptive for your whole system. NoSQL databases, on the other hand, have dynamic schemas for unstructured data, and data is stored in many ways. For MongoDB, the data is document-oriented. This flexibility means that you can work with your data without having to first define their structure, and each individual entry in your database can have its own unique structure. In most situations, SQL databases are vertically scalable, which means that you can increase the load on a single server by increasing things like CPU, RAM, SSD. But NoSQL databases, on the other hand, are horizontally scalable. This means that you handle more traffic by adding more servers in your NoSQL database, or in the case of MongoDB, by sharding, which we'll go through later. So it's like adding more floors to the same building, in the case of SQL, versus adding more buildings in the neighborhood in the case of NoSQL. And the latter can ultimately become larger and more powerful, making NoSQL databases like MongoDB the preferred choice for large or ever-changing data sets. In MongoDB, databases hold one or more collections of documents. Drawing parallels between this structure and that of a relational database, collections can be seen as the tables of the database and documents the rows of values in the table. The documents follow a JSON-like object format, which makes MongoDB very adaptable to real-world requirements, since a lot of things nowadays are abstracted and represented by objects in code. The features of each document are called fields and are similar to attributes or the columns in relational databases. So we'll now try to create and query documents using Pymongo, a Python module allowing you to interact with a MongoDB database. So to practice doing this, right, we'll use a tool called Code Collab, which is an online compiler, online editor and compiler. Okay. So once you're on Code Collab, you can log in and you arrive at the project page. So once you're on this page, right, you can start by creating a new project by clicking the plus button over here beside my projects. In this case, right, since you want to use MongoDB, right, we'll have to select Python Flask, because Python Flask has built-in support for MongoDB. And you can name this whatever you want. I'll name it MongoDB. And you can pick the server that you want your project to be created in. Right, and once you've created the project, you can just simply click on the project that you created, and it'll bring you to a code editor. Okay, so you won't actually need this code, so you can just delete it. And first, what you want to do is you want to import Pymongo to be able to interact with your database. So we can type from Pymongo. So we can, from Pymongo, import a Mongo client. So Mongo client is a class that it represents your database. So you can create database client through this class. So after that, we want to define our database. So we'll have to first define our client. So client equals to Mongo client. And in the brackets, it'll be the URL that we need to connect to. So in this case, right, we can use localhost to host our database. So the URL would be MongoDB // localhost on port 27017. After that, we can create our database using this client. So our database, maybe we'll create a database, so we'll do client, and we'll just access the school untyped. And so a school will have its students, right? So in this school database, right, we can create a collection called students. And it's very similar to how we create our database. First, right, what we want to do is we want to populate our database with data. If not, we can't do anything. We can't really do anything with it. At this link, right, I have 5 objects. So once you go to this link, you'll be able to see a couple of objects here, and each object represents a student. So we have 5 students here, and we have the fields. We have their name, we have their address, we have their scores for a couple of tests for the subjects that they take, and we have their shirt size, just in case the school wants to, print shirts, school shirts or something. First, we want to populate our database, so we can go back to our ways to insert documents into a collection for Pymongo. You can either insert one by one, or you can insert many documents at once. So we'll go through both of them. To insert one document, we can call the insert one method of the collection. So students insert underscore one. Right here will be the document, the object that we want to insert into the collection. So we can just copy and paste the first document here, the one where the name is Isaac. And if we run this, yeah, so it's the server is not running because we're not actually running a server. We're just testing out the MongoDB queries. You notice that nothing is being outputted to the terminal here, and that's because we're not actually retrieving anything from the database. The database is being populated, but we have no way to see it. So what we can do is we can do a simple query to read the documents in the database. For this, we will use the .find method. So we can do results equals to students .find. And if we pass in an empty document, it will return us all the students. Right, the document is a query object, but which we'll be going through later. So if we do this, results will now contain all the documents in the students collection. So we can just print results. You can see that it doesn't actually return a readable version of the documents inside, right? It returns a Pymongo cursor object. What the cursor object is it's actually an iterable where each element contains the documents. So what we have to do is we have to iterate through this cursor object, and for each object we can just print it out. We'll return the document. We can just define a simple function here. Define print result maybe. We take in a parameter results, and we loop through results. And we can print result. So if you replace this print function with our new function pResult, yeah, we can see that we get the document representing Isaac, right? But this format is not very nice to see. Everything is bunched up into 3 lines. What we can do instead of simply printing the result is we can use something called pretty print. So we can import the library from eprint, import eprint, and instead of printing the result, we'll pretty print the result. And if you do this, you can see that the result is much more nicely formatted in the terminal. So another way we can insert documents is by inserting many at once. And instead of calling the insert one method, right, we'll call the insert many method instead. So we can do students insert many. And in this case, right, the parameter will be an array of documents. So all the documents that you want to insert into an array or list. So you can go back to the just paste it link, and we can copy and paste the rest of the documents representing the students into a list. We have a list here, and we'll just paste everything inside. And if we run this now, yeah, you can see that the collection is now populated with five objects. Now that our collection is populated, we can start doing like some simple queries. In Pymongo, right, you can do a simple query like this to retrieve all the documents in your collection. But in this object, right, you can also filter the documents that you want to retrieve. For example, right, if I wanted to retrieve all documents where the name field was Mary, we could do that's fine. Then in the object, right, just put name : Mary. If we run this, we can see that the object of Mary is returned, not any other document. Specify more conditions as well, like you can use the in operator. So an example would be using the find method again. In this case, right, let's say I wanted to return all documents where the shirt size was either medium or large. So in this case, my query object would have shirt size. And what we can do is, in this value, right, we can pass in another query object where we specify the operator in. So all the operators have to come after a $sign in and colon and an array with the elements M and L. What this does is find all documents where the shirt size corresponds to whatever is in this list. So if it's either M or L, then it will match. Then it will be returned. So if we run this, yeah, we can see that it returns Isaac, Felix, and Bob. It doesn't return Mary because Mary's shirt size is S. We can also do AND conditions as well. So we can use the same method. And in this case, right, let's say we wanted to find everyone with a shirt size of M and who lives in 10 Downing Street, on 10 Downing Street. So what we can do is we can simply these two fields in the query operator separated by commas. So shirt size of M, you will do shirt size of M and comma, and we can do address colon 10 Downing Street. So in this case, it returns Isaac. Notice that there are two people with shirt size of M, Isaac and Bob, and there are two people who live on 10 Downing Street, Isaac and Mary. So in this case, by using the AND operator, we sort of like find the intersection between the two sets. So besides these conditions, right, we can also specify the range. Here we have the test scores, and let's say we wanted to find everyone who got less than a 90 for English. So what we would do is we'll call the same find method. In this case, our object would have key of scores for English. Because English is in scores. When you have like embedded dictionaries, right, like these, when you have embedded documents, you access them in a way that that Python would, right, with like classes and such. So your outer dictionary and then dot then the field that is inside this field. So scores.english will access scores first, then we'll find English in scores. And we want this to be less than 90. So we can specify the condition less than 90. If we do this, we retrieve both Isaac and Mary. Because Felix does not take English and Bob has an English score above 90. We can also specify all conditions as well. So we copy paste the same thing. And in this case, the operator comes first. So we'll do $or, and the value, right, we'll put an array. So the query objects, right, in this array will be matched by the OR operator over here. Let's say we wanted to find everyone whose score for English was less than 90, and everyone who has a shirt size of M, for example. So we would just pass in this query object and a comma, and we'll pass in the shirt size M query object. So it's just this one over here. Right, so you can see that it returns not just Isaac and Mary, but it also returns Bob. So in this case, right, notice how all of them take English. So this will be a good chance to demonstrate the sorting method as well. When you query documents from a collection, right, you can also sort the return. We can sort them by their English scores. To do so, right, all we have to do is we just call .sort, and we can specify the field that we want to sort the return by. So we can sort by English. So scores.english. So now the return is sorted by English from lowest to highest. You can also sort in descending order. So all you have to do is add an extra parameter and pass in -1. -1 will tell the database to return the documents in reverse order. So now the order is flipped, with Bob being the first item and Mary being the last item. So we can also update documents. So let's say we found out that Mary was cheating on a chemistry test, so she deserves a 0. So what we can do is we can do students, and we call the update1 method. Update1. This is a bit different. The first parameter, right, will be a query parameter. First, we have to find, then we have to set the document into a new value. So we have to update the document that we just found. So first we pass in the query parameter, and since it was Mary that cheated on the test, we can pass in name Mary. And for the next parameter, we'll have another object. And this time we'll call the set operator. So set, and we want to set her chemistry score to 0. So this would be scores chemistry and 0. So after this, we can just we can just retrieve Mary from the database. So now you can see that her chemistry score is 0. So we can also delete documents. Let's say Mary was too ashamed, so she decided to leave the school. We can call the delete1 method now. So students delete1, and we pass in just a query object. So name Mary. And if we retrieve all the students, we can see that Mary is no longer a document in the collection. So we are done for the basic CRUD operations. Now we'll just go through more features about MongoDB before we do the blog app. So another feature of MongoDB is its ability to index a collection, which allows for the efficient execution of queries. So indexes are special data structures that store a small portion of the collection's data set in an easy to traverse form. The index stores the value of a specific field or set of fields ordered by the value of the field. And the ordering of the index entries supports efficient range-based query operations, for example. In addition, MongoDB can return sorted results by using the ordering the index. We'll go through an example of an index here. So in this case, we have a collection of users with various scores, like just now. Right, so we want to retrieve the documents of all students that scored lower than 30, and we want to sort in descending order. So in the index data structure for the score field, represented by the bar above, we can simply access the section of the array between 0 and 30. So we can return the documents in that segment in reverse order. In this diagram, we can see how the index is linked to the collection of students, where the collection itself is not sorted, but the index is. So you might be asking why MongoDB chooses not to sort the students instead. And that's because there might be multiple fields you need to query by range often. And creating multiple indexes for those fields is a lot more effective than sorting the collection, which can only be sorted by one field at a time. In MongoDB, every document upon creation will also be assigned an object ID value, which can be considered to be globally unique. This serves as something like the primary key in a relational database. In addition to this, MongoDB creates a unique index on the underscore ID field during the creation of a collection. The underscore ID index prevents clients from inserting two documents with the same value for the object ID field. Another important feature of MongoDB is replica sets, primarily to offer data redundancy and high availability. So we can maintain the durability of data by keeping multiple copies or replicas of that data on physically isolated servers. This redundant data streamlines and safeguards data availability and durability, which is especially useful if a server crashes or if you experience service interruptions or hardware failure. So your data only resides in a single database. Any of these events will make accessing the data impossible. But thanks to replication, your applications can stay online in case of database server failure, while also providing disaster recovery and backup options. So in MongoDB, replication is achieved through a replica set. Writer operations are sent to the primary server in blue, which applies the operations across secondary servers, replicating the data. So the primary and secondary servers, right, will have the same data. If the primary server fails through like a crash or system failure, one of the secondary servers takes over and becomes the new primary node. And if that server if the previous primary server which broke down comes back online, right, it will become a secondary once it fully recovers, aiding the new primary node. So earlier we talked about how MongoDB supports horizontal scaling. Horizontal scaling involves dividing the system dataset and load over multiple servers, adding additional servers to increase capacity as required. So while the overall speed or capacity of a single machine may not be high, each machine handles a subset of the overall workload, potentially providing better efficiency than a single high-speed, high-capacity server. Expanding the capacity of the deployment only requires adding additional servers as needed, which can be a lower overall cost than high-end hardware for a single machine. The trade-off is increased complexity in infrastructure and maintenance for deployment. So we have a load balancer in orange, and the load balancer efficiently distributes incoming network traffic across the database server pool, so across all the servers of the database. It's important for the load balancer to route the same client to the same server, as data in one server may not be a complete replica of the other. In MongoDB, this is achieved through sharding. So MongoDB sharding works by creating a cluster of MongoDB instances consisting of at least 3 servers. That means sharded clusters consist of 3 main components: the shards, which are represented in white in this diagram, MongoS, which is the router represented in orange, and the config server represented in blue. A shard is a single MongoDB instance that holds a subset of the sharded data. So each shard will have its primary and secondary nodes and everything. Shards can be deployed as replica sets to increase availability and provide redundancy. And the combination of multiple shards creates like a complete data set. So for example, a 2 terabyte data set can be broken down into 4 shards, each containing 500 gigabytes of data from the original data set. They are not like replicated across the shards. So if you have a 2 terabyte data set, you won't have each shard having 2 terabytes of data. MongoS acts as the query router, the load balancer, providing a stable interface between the application and the sharded cluster. So this MongoDB instance is responsible for routing the client request to the correct shard. Lastly, at the config server, we stores the metadata for the whole cluster. And one very useful tool MongoDB provides is the global cloud database service, Mongodb Atlas. It's a worldwide cloud database service for modern applications that guarantees availability, scalability, and compliance while complying with data security and privacy standards. We can use MongoDB's robust ecosystem of drivers, integrations, and tools to create faster and spend less time managing our database. You can also choose from various cloud providers like AWS, Azure, GCP, and also the region you want to start your server in. So what I'll be making today is a simple blog website, which allows you to read and write simple posts. We'll be using Flask for this, which is a lightweight Python web application framework. It's designed to make getting started with web application quick and easy, with the ability to scale up to complex applications. So first, you can start by creating 2 projects in Code Collab using the Flask template, of course. For the first one, you can just create a Python Flask project. For the second one, I would like you to fork the project from this link over here. You'll be able to simply fork the project over here by clicking this button on the sidebar. So the reason why we have two projects set up is one will be our blog app, which is the one that you fork, and one will be our API, which acts as an intermediary between our blog and our database. So the reason why we use an API instead of simply giving the app direct database access, right, is because if you have let's say if you have like a very large database containing millions of records, right, it's not enough to do like simple CRUD applications. Normally, people will start doing procedures, which is like pre-processing the data before you insert or before you query or after you post-processing after you retrieve the data from the database, for example. In this case, right, you want to like set what can and cannot be done to your database, what procedures can and cannot be done. So normally, if you're working as a team or if you're working in an organization, an API will be created so that people can't do anything they want to your data. So it provides an added layer of security. So we'll start by doing the API first. So you can navigate to the Flask project that you just created, not the fork one. So here you can see a template has already been laid out for you. So this just runs a simple Flask app. So if you press run over here, you can see it returns hello world. So this is going to be our API. In our API, we'll have different endpoints, which each correspond to different procedures that you can do to the database. Paste in the URL. Once again, it's MongoDB //localhost at port 27017. Then we'll make a database called blog. And we'll make a collection called post. Oh. So for API, right, we'll be creating two endpoints. The first endpoint would be to create a post document in the post collection. And the next endpoint would be to query all the posts so that we can display them onto the app. We can create a new endpoint by typing app on route. And the first parameter would be the name of our endpoint. If I wanted to create the endpoint that allows us to upload the post, I would name the endpoint upload. And in this case, we can accept the post method. Below this, we can define a function for upload. Since we are only accepting post methods, right, to post requests to this endpoint, we can take the data from the post request and we can simply insert it into the database. Here, we need to import requests from Flask. To allow us to access to the data was posted to the endpoint. We can insert a document to post.insert1. Normally, if you think of a blog post, it has a title and it has the content. So we'll be doing something very similar to that. So we have a document has two fields, the title and the content of the blog post. So title will be the title that was sent in the request, and the content will be the content that was sent in the request as well. To get access to the data that was sent in the request, we'll do request args, which stands for arguments, get, and the name of the field. So in this case, it will be title. We just standardize everything. In a similar vein, the content would just be request.args.get content. So we have to return, the function has to return something. So we will just return uploaded. So we want to make another endpoint. We want to define another endpoint to retrieve the document. And so we'll just copy the app route for this one. But instead of upload, we'll do query, for example. And this will be a get method because we are getting stuff from the database instead of posting to. And we'll rename the function as well to query. So here we'll call the find method, right? Since you want to retrieve the documents. Post list equals to post.find. But since this is a cursor object, like what we went through previously, we want to convert this into a format that is more workable with. So we'll convert this to a list. But also remember that every document in MongoDB has an object ID, and this object ID field will be returned when we do post.find. So we don't really have a use for this object ID. What we can do is we can omit the object ID field when we retrieve the documents. So how we do this is we put in an extra parameter in .find, and we just pass in what we want to retrieve, right? So underscore ID, which is the object ID field, and then we'll just put 0. So this will tell the .find method to not return the object ID field when we retrieve the documents. It's only returning the title and the content. So in this case, we don't want it to just return uploaded. We want it to return the list of documents. What we can do here is import JSON-like from Flask, and down here, what we can do is we can return a JSON-ified version of an object with the value post list. So we can return JSON-ified. We have an object here where we have a post key. There will be post list. JSON-ified just puts in JSON format. Because when you return stuff, right, you can't exactly return like Python objects, like dictionaries and stuff. So what? CSV5. But how you use CSV? I mean, I can understand why you would CSV if it's like an SQL. Normally CSV will fit more like relational databases, because CSV fits more of like into that table format. Yeah. But for MongoDB and other NoSQL databases, we would prefer using JSON, because JSON looks similar to the document model. So this is our API done. Now we'll head to the BuildingBloCS template. I created all the HTML files for you. So all we have to do is edit min.py. We can start by importing some modules from Flask. So from Flask, import Flask. You want to import some stuff as well, like render template. Render, oh wait, let me increase the font size. Render underscore template. So what render underscore template does is it renders the HTML code under the templates folder. And we also want to import requests. We also need the requests library with an S. So this library is different from this library in the sense that request is in Flask. So what this does, right, is it allows you to handle web requests. Like you can check what request method the user uses to access like web page, for instance. But this request library allows you to make requests like URLs. This is to handle requests in your app. This is to make requests to outside your app. And we also need to import URL library, which is just a URL string formatter. So first, we want to create our app by doing app equals to Flask underscore underscore name underscore underscore. At the end of the script, we want to run our app. So if underscore underscore name underscore underscore is main underscore main, we call the run method. App.run. So in the middle here will be all our app routes. So in this case, we will have two routes. The first one for interface where you can write your blog post, and the second one, an interface where you can read the post that you have written. We can start by defining app routes. You can just copy and paste the template code here from your API. So for the first one, we'll just leave the endpoint blank. So it's just a slash, and we can include the get method as well. So the endpoint supports get and post methods. This route will be for you to write your articles. So when you reach the route on a GET request, right, it just shows you the index.html page where there's a form and you can input the title and the content. But if you get that on a post request, right, it means that you have submitted the form. When it submits the form, right, you want to take the data in the form and you want to send a request with that data to your API, which will then pass the document into the database. So we can rename this function write article. And we want to check whether it reaches on a post request. Because if it's a post request, right, then you have the data that you want to upload to your database. So if request method post, we can get our data from the request. In index.html, right, there are two inputs, one called title, one called content. Both of them are text inputs. What we can do is we can grab the title and the content field from the request. So can do title equals to request form, and we access the title field. And it's the same for content. Now you want to send the title and the content over to the API in a post request. First, we can start by defining the URL of the API. So URL goes to a string. Then we switch back to our API project, and we can see here, right, there's a URL over here, right? So we'll copy this URL and paste it in here, and the endpoint is upload. Endpoint upload. Now we want to pass URL parameters into this URL. We want to pass two URL parameters, the title and the content. We can start by putting a question mark, which tells the browser to start interpreting whatever is after this as parameters. So title will be equal to title, as in the title over here, and the content will be equal to the content, as in this one. But the problem with this is that the title and the content that the user wants to write, right, might have special characters, might have spaces, and this all needs to be taken into account. What we need to do, right, is we first need to pass the title and the content into a format where it's a valid URL. So you can do URL library pass underscore plus the title and wrap the title in the bracket. And it's the same for content. We can make a post request to our API. So we can do request with a S, post to the URL. And after that, we can just return whatever is in index.html. We return render template index.html. So we run this now. We can see that we have two text fields, block title and content. So we can type in the block title, like example title, and content, example content. And we can upload the post by clicking on the button here, which will send the title and the content as a post request into this app route, which will then trigger this. So it will post the title and the content to the API, which will then create a new document in the database. So make sure your API is running. Make sure that the button here says stop, which means it's running. And if we click on upload post, we can see that there's a new post request, right, in the API. So it means that the new document was successfully created if no error appears. You might notice there's another button here, visit blog, but the endpoint is not, the route is not being served yet. So we need to add another app route for viewing the post. We can use the route blog, for example, and in this case, we can allow the get method. And we have to rename our function, and we can rename this read articles. So in this case, what we want to do is we want to send a GET request to our API, and we want to retrieve all the documents and list them out. So if you see in the post.html, right, here we have some Jinja. Here we have some Jinja. So what this does, right, is it retrieves the post, the POSTS post list in that's passed into the render template, and it will display the title, the content, and a line separator for every post in the list. So what we can do is send a GET request. So response equals to request .get, and we want to send it to this this URL, the URL of the API. Instead of upload, it will be the query endpoint. And in this case, there's no need to pass in any URL parameters because it's a GET request. So after this, we want to return a render template with while passing in the post list. So we can return render template for HTML. And post equals to. So in the response, we did a JSONified version of this dictionary where the post list was a value under the key post. So what we can do to access it is we can do response and to access the post like this. But keep in mind that we JSONified the dictionary. So here we need to do .json. So response.json, and we access the post value. So now if we stop the compiler and we run it again, we can just write a new blog post for good measure, example title true, example content true. And when we click on visit blog, oops. Now it works because I omitted object ID from the return. But I did that already. Yeah, I did that before on the first time. Then the error happened still. That's odd.
I think this works is okay lah.
Yeah. Yeah, but it should work like this. So you can see the example title and the example content. All the on-site participants. Is everyone getting the same problem of the JSON decoder not working? Because some on-site participants are getting it, and I have no idea why it's happening. The URL to the Mongo API. Okay. Wait, the Mongo API template is just you can create your own. But I'll share with you the completed projects. This is the one for the API. And this is the one for the app. Okay, if the online participants don't have any issues, right? That's pretty much the end of the workshop. We all can try out like creating more endpoints in the API, maybe for like updating or deleting your post, for example. Okay, we are done with the workshop. Thank you all for attending.
Thank you.
All right, thank you.